Okay guys, in this video we are going to solve an inequality that has the variable on both sides of inequality. Okay, now the first thing we notice is that we have x, and when we see x and there's no number in the front, we can insert a number, and that number is going to be 1. So 1x is the same as x because multiplying by 1 does not change the quantity. Okay, so then we want to have the variable x, let's say, on the left side. That will probably be easier, although you can argue that you'll get a negative coefficient of x, but we'll deal with that in a second. Okay, so that's going to cancel it over here. And on the other side, we get 1x minus 6x. So that's just, if you perform an operation on numbers, 1 minus 6, that's going to be negative 5. So this is negative 5x less than or equal to negative 10. Now, what operations do not change the inequality sign? Addition, so you can add a number to both sides of the inequality and nothing changes. Subtraction, again, nothing changes. Dividing by a positive number does not change, or multiplying by a positive number does not change. But if you are dividing by a negative number or multiplying by a negative number, the inequality flips. So instead of less than or equal to, it will become more than or equal to, and vice versa. And here, this is very important to remember. Anytime you are dividing or multiplying by a negative, the inequality switches sign. So here I'm going to divide by negative 5 because I want to get rid of it and isolate x. And then this inequality is not going to stay less than or equal to. It is going to switch to greater than or equal to because I'm dividing by a negative. So on the other side is negative 10 divided by negative 5. You can use a calculator if you want. And that's just going to be x greater than or equal to 2. So here I can just say, okay, that's x greater than or equal to 2. Okay, now I have to represent the solution on a number line. So this is greater than or equal to, right? Because the sign does not look like an L. Okay, so I find 2, so 2 is going to be somewhere over here, and I want to shade everything to the right of 2. So this is going to be all of this, and remember on the right hand side we've got the infinity. So how do I write this in interval notation? So we start at 2, we go to infinity. Infinity is never included, it's always parentheses. Now 2 itself is going to be included because the inequality is not strict, because we're saying more than or equal to. So that means this is going to be a bracket. And then when we graph it, this is going to be a solid dot. Okay, now let's go ahead and graph this. So this is going to be x greater than or equal to 2. So we're graphing everything 2 and higher. This is going to become a solid dot. In interval notation, if you go to the interval, this is going to become start at 2 and go to infinity. Okay, now another thing you can check, just to check for yourself, like is this right or not, is pick a number somewhere on the interval, let's say 3, plug it into the inequality just to make sure and see if it works. So if I plug x equals 3 on the left hand side, I would get 3 less than or equal to 6 times 3 minus 10. Okay, so this is 3 less than or equal to, this is 18 minus 10, and that's 8. And is 3 less than or equal to 8? Yes. So that's just a double check for me, just to make sure I didn't do the wrong side.